Hi, and welcome to this video on energy. Today we're talking about kinetic energy.
The energy of motion.
Kinetic energy comes in many forms. It comes in vibrational, which is the random vibrations of molecules on the small scale. There's rotational, which from spinning. Translational, which is objects moving in a line or in a notable direction. And a couple others that we won't really talk about at all. For simplicity's sake, right now we're going to stick and focus on translational, which is objects moving in a notable direction. Typically, we're talking about cars, falling objects, the stuff we've been talking about all year. Translational kinetic energy is the net
Movement of an object.
specifically moves from point A to point B. We're talking about discrete and notable movement. Roller coasters, car driving, etc. Translational kinetic energy is the only type of energy that we're going to be talking about right now. It's going to be abbreviated as either KE or EK, and it has an equation of 1/2 mv squared, where m is the mass and v is its velocity. Now, unlike forces, unlike kinematics, the velocity direction here doesn't matter. A 1,000-kilogram car going north at 30 miles per hour has the same amount of kinetic energy as a car going east at 30 miles per hour. The direction doesn't matter for kinetic energy.
Just how fast it's going.
Which makes it a lot easier to work with in some senses because all we need to do is know how fast, not the direction. In this example, the 1,000-kilogram car would have 1/2 times 1,000 times 13.41 meters per second squared joules of energy, or 89,914.05 joules. So all we need to do is just, again, know how fast something's going and know its mass, and we can find its kinetic energy. So let's take a look at an example. Here we've got a book sitting on a stool. The stool is 1 meter high. If we go use our kinematics equations, we find that right before it hits the ground, the instant, it's a little space there. Before it hits the ground, it's going 4.43 meters per second. Go ahead and calculate the kinetic energy of the book at each of these points, the black and blue. If you want, you can also do the gravitational potential energy for some comparison. Go ahead, give it a try, check back when you're done. Okay, now that we've come back, we can see that the kinetic energy of the book up here is 0 because it has 0 velocity. It's not moving. 1/2 times mass of 4.50 times v naught squared, which is 0. 0 squared is still 0 times 0 is 0. It has 0 kinetic energy. Whereas right before it hits the floor, 1/2 times 4.50 times 4.43 squared gives you 4.41 joules. If we look at the gravitational potential energy, however, on the ground it'll have 0 gravitational energy. But up here on the stool, it has 0.45 kilograms times 9.8 times 1 joules of energy, or 4.41 joules. The fact that this energy here and this energy here are the same amount isn't a coincidence. We'll talk about why a bit later, but things to think about for now. If you're able to calculate that and understand what's going on, awesome. If not, make sure you ask questions. Regardless, have a good day.